Oh, hello everybody. How's everybody doing on this Thursday? Where is my chat? Yeah. Hello. So, hello guys. So, last time we tried to we went to map, filter, reduce, and everything in between. We tried to find I said it before, that's quite important in JavaScript because any any data can be transformed just with map, filter, and use. And you will see I will go through some examples today that will be much harder to understand and much harder to code. But also we need to go with a little bit more about for loops. So I will show you the old school for loop, like if you try to program in C or C++ or C# or Java. There is an old school for loop, and also there is something called for off. And after that I will go a little bit more about arrays and about project that will be doing on Saturday. And then I would like for all of you to prepare all the questions that you have to ask me or projects to show me, so we can go to the second exercise that we've done like last Saturday, and we can go through the like examples, or at least through my own solutions how to do that. Isn't it Thursday, right? It's Thursday. Yeah. So tutorial, yes, it's Thursday. So yeah. So I'm if you have download again, if you need to download any the repository, you just go to Lockdown Learning and you press download zip, or you go to your terminal or your command prompt, go to the Lockdown Learning and say git pull, and it should be already up to date for me. So I'll paste again if somebody is lost. Oh. Here we go. So I have opened back like the index.html from the last time, like for map reduce. You can see it in URL. So I will go back to the script in for map reduce folder. I commented everything except the two arrays we have on the beginning, just so I can show you the for loops. So most like when you're doing the loops like for each and map and reduce so on, most of the transformation you will do is with arrays or something like that. But there is also an old school for loop that is like taken in JavaScript from like C or C++ or Java or something like that. And if you know how to write it in any other language, you will know how to write it in JavaScript. It's the same thing. So I will show you an example. So what we can do actually is right on, and we can, we can create a new array. So we can create a new array that has numbers from 1 to 5. So we can do it with the old school for loop. So if you say, let's say, let result, and what we can do now is write something like this. So yeah, just try to follow me in this one. So for, open your brackets, and then say let index equals 0, index is less than 5, index is equals to index plus 1. So this is kind of confusing, and we'll explain everything this line is saying. So what we can do for now is just console log index. So if I save it like this, and we try to go, let's try this out. We can go to our HTML page, open the console and refresh it. We'll get like 0, 1, 2, 3, 4. So what actually this does? These three are, you won't find like any other syntax in JavaScript written like this. This is kinda special for JavaScript. So it's kind of a special way of writing the for loop. It's similar to some other languages, and it's not really similar to anything other in JavaScript. So what this does is actually, it says, let's define a variable. You can call it anything. It can be index in this example. And we will do something until this part of the code is, or while this part of the code is true. So while index is less than 5, we will increase index by 1. So what this will do, we will define index with value 0. Then each time after this part in the brackets is called, or after it finishes, index will be increased by 1. So what will happen here is actually we'll get console log first time 0, then console log 1, because index is increased by 1. Index is still less than 5, so it'll be 2, after that 3, and after that 4. So the sixth time that it gets in there, index will be 4, increased by 1, and index, so this statement here will be false, and that's why it will stop. So you won't see in like modern JavaScript apps written something like that, but it exists in JavaScript as well as any other language. So if you copy paste this this piece of code, it can be used almost in any other language with some minor adjustments. Let's say let in some languages doesn't exist and there is a var, or if you are writing in some languages, you need to define what type of variable that variable is, you will need to define it in here. But we can do it like different ways. We can say like index is less than 10, and then we can increase it by 2. So let's try to rerun that. So I just changed, so index is less than 10 and index is increased by 2 every time. So when we call this, we will actually get 0, 2, 4, 6, 8. And also what we can do, actually, we can put it in our result array. And how to put something in result array, you can do it like with use of something called push. So what push does is actually it just puts numbers, puts some objects or items or numbers in this case into array. So we can console log result at the end of it. So let's try to run this. So we change the index to index is less than 10 and index is equal index plus 2. And we are pushing the result into the array. So index is pushed to the result and we console log it at the end. So if we try to run this, we will actually get an array with 0, 2, 4, 6, and 8 in there. I mean, there is an easier way of creating arrays where you need to increase numbers or do with some, but let's not go into this. This is quite okay. The one thing that we can kind of So also what I want to do today is change a little bit of syntax so it can be more easy. It could be easier to be read. So the problem with JavaScript, you can write the same thing in like 100 different ways, and there are some ways that are more readable than others. So in this example, what we can do, or I can show you, let's go to console. You can, let's define some variables. Let's say number equals 1. If you want to increase that number, so by 1, or add to the, we want to increase the number value by 1, we can do number is equal to the number plus 1. So when we say number, it will say hi Tapmir. So num will be 2. Okay. Also, you can clear it by calling a clear function. So our num is at the moment is 2. But if you can write it like in a different way, it's just a syntax difference. You can write it like this. What will happen? Number will become 3. So this is like plus and equal here. You can also do minus and equal, and you will get decrease by 1. Also, what you can do in here is multiply and equal. It will become 4. So 2 numbers, 2 times 2 is actually 4 in this example. There is also another way to increase it by 1, but only if you want to increase it by 1. It's actually to call, num plus plus. Okay, but it's increased, right? In this example, yeah, okay, it becomes 5. It's a long story why it prints out the here 4, and after you print it, it's 5. But so you have 3 different ways of writing, so to increase. Let's just write it out. So num equals num plus 1. You can say num plus equal 1, and you can also say num plus plus. So all of these 3 ways are okay. They're not completely equal, they're almost exactly equal. In this example that I wanted to show you, they are totally equal. What I prefer is writing like this. I liked, so this one here is the shortest, but it also got a lot of different problems, and I don't want to go into them. So I really prefer this way of writing. They're kind of again there are restrictions in JavaScript. So, but this way is quite readable. So you can see here that we can define an index that equals 0, index do something until index is less than 10, and then you can increase index by 2. Okay, we won't be like, I don't know, like in our project in Saturday we will using this anywhere, so it's just a good thing to know. Another way of writing everything is, so okay, let's do an example with pizzas with these 4. So we can do let index equals 0. Again, we can define index equals 0 another time because it's inside these brackets here. So it's not the same function, not the same variable. Oh my god, function. Well, I haven't drank enough coffee today, it seems. So what we can do is, let's go through all pizzas and let's print it out. So it's pretty the same thing we wrote before, only we will use pizzas.length except hard-coded number here. So what we can do here is just write console log pizzas and how to get a pizza item in there. There is a way we can get anything from this array, and it's written like this. So what this does is actually, let's get an item from pizzas that's on position of number that's inside this bracket. And if we try to run this, let's try it, we will get calzone, Hawaiian, frutti di mare, margherita. You can see this, those are our pizzas from the last time example. Yeah. So it's almost the same. We changed a little bit. So these numbers can be variables without problems. Also, the index can be. It doesn't need to be started on 0. It can be started on 10. It can be started on any number, but it should be a number. And also this way. You'll need to have some way of increasing that index or changing that index, because this for loop will loop until this part is false. So if you do something kind of stupid and write like just true here, it will go forever. So for loop will go forever and ever. That's why it's kind of scary and kind of dangerous, because if you can make any part of the code go infinitely, there is a way you create a logic bug or logic mistake, and everything goes to hell and back. So the other way of writing for loops is something called for off, and it has a special syntax as the for before we wrote, and something like this. So we can do const pizza of pizzas console log pizza. I will just paste it here. So again, you will need to have an array here, and then what you can do is just loop through the whole array and console log it. So this code is the same as this code, and it's also the same as this code here. So it's for each function so these three for loops or for each here in this example they will have the same result. So we can rerun it and you can see it. Calzone, Hawaiian, frutti di mare, margherita, calzone, Hawaiian, frutti di mare, margherita, calzone, Hawaiian, frutti di mare, margherita. Okay. Totally the same results. If you have an array that you need to iterate through or to do something, I prefer this way of writing, so for each. And if you don't have an array, or you need to create an array, or you need to do something iterative, I prefer doing this. This way is kind of strange to be put in JavaScript, but okay, it's just a way of writing code. If you wanna ask me like what's the better way of writing, you can choose anything of those. They are totally the same. I just wanted to say that writing code, you need to be extra careful when writing for loops like this, because if this is true, it will go infinitely and it won't stop ever until you just close the browser if you're running in the browser. So these are just three different ways of writing for. It's not okay. There's also one other, but it's not really useful. So it's called for in way, and I won't even show you because it has too much problem. So the for in, it was like the second way of implementing for loops after this one, added to JavaScript, and it just got too many problems to be used. They're probably thinking of making it obsolete. I haven't checked it out though. Okay, so that's about it about for loops. So if you have any questions and you're just if you just got online now, if you have any questions, just write them down and ask me in chat. I will do quick question and answer part on the end of this lecture. Okay, and if you've went a little bit through project, you will see a new folder called Pokemon project. Let's open this index.html here. Let's open it in our browser because we will be doing like a lot of examples here now. What I wanted you to show you is actually the data. Let me just open. I want to show you this data.js here. So what actually is this data.js? Is actually every Pokemon that exists until today. Why I like to pick Pokemons is not that I'm like big fan of them of anything, but this is actually just a giant array. It's not like too large, so it has like 1 million of rows, but it has about so 17,000 lines or 16,500 lines. So this is actually all exported to a Pokemon constant. And if you go to a browser and you enter Pokemon, you will get all 809 Pokemons here, and you can check it out. Yeah, so these are like first generation Pokemons, and I remember all of them. Probably I can. So I was like a kid when Pokemons started, so I know a lot of them from first generation, but there are like 809, like 9 generation or something like that. But you have all the data about them here. So what are the names, what are the types, what are base stats in here, also how they're said in French and Japanese and Chinese. Unfortunately, I don't have installed the Japanese and Chinese translation in my browser, so I have some random strings in here, but you can ignore it at the moment. So what I wanted to do today is go through this array and try to do some different map reduces on this array, so we can be prepared for Saturday, because Saturday we will make a Pokemon, let's say Pokédex, Pokemon list, which will be interactive, and it will be your first website, like real serious website. It will do something different than writing out you're working on Windows. So let's see our script. So if you go to index.html, you will see that data.js and script.js is included in here. So you can use everything in data.js in your script.js, because all the JavaScript in your HTML goes like it's loaded like one by one, like line by one line. It's not really like, there are some exceptions, but let's say this is fine. Okay. So we tried console logging, like just Pokemons, so like Pokemon, and you'll see the result in your console, in your browser. But what we can do here is actually, let's just map the whole array and just to get the names out, just Pokemon names out, like English Pokemon names. Let's do it like that. So if you remember, what we have done here is let's say we'll console log it. We won't like save it in any variable or something like that. And we said like Pokemon dot map, and after that we will write some function in here. So that function will be actually function get English Pokemon name. You will get Pokemon as this map, and we can return Pokemon name English. The problem with Pokemon, so Pokemon, it says Pokemon as in plural and in a singular, so there is no Pokemons, there are Pokemon, so well. And we can say get English Pokemon name. So what this will do is actually it will print a new array of Pokemon names, because this get English Pokemon name will call this function for every item in this array, and there are 809 of those, and it will return Pokemon.name.english, and that will be equal to names of Pokemon, so Bulbasaur, Ivysaur, Venusaur, and so on. So let's try this. Yes, we got all 809 Pokemon in here, just the names of those. But I want to show you another way that you can write a function. So JavaScript has two different ways of writing functions. There's some difference we will show you the difference in the future, at least when we will be talking about classes. At this point, they are almost totally the same. I don't know that we will get into the differences, or we will see the difference while writing code. So the other way of writing functions is something called arrow functions, and they are the definition of arrow. So you'll see that syntax of arrow functions is more similar to defining a variable than defining a function. So let us try. Let us try writing get French Pokemon name. So when doing the arrow functions, you should write something like this. So const get French. Oh, I'm illiterate. French Pokemon name equals to something like this. I will paste this into chat so everybody can follow me. Name French. So try this out. So okay, and we can finish this with a little bit of copy pasting and adding get French Pokemon name. Those two ways of calling, writing a function and calling them, the result will be totally the same, except one will be all the English names, other will be French names. At this point, you can use both syntaxes, and it's totally fine. Why there are some differences, but they are pretty advanced. And why I'm showing you this? Because a lot of like modern JavaScript code is, or at least in modern JavaScript code, this way of writing functions is preferred. Also, this is my favorite way of writing functions, and you will see in the future why, because there are some good things about it, and you can create your you can make your functions a lot shorter and more readable while writing it like this. We can run this. Okay, it's totally the same. Oh, I don't have the French letters also, so it's yeah, okay. But so Bulbasaur is Bulbizarre, Ivysaur is Herpizarre. So yeah, yeah, okay. Okay, French people. They need to have special names of their Pokemon. So this is just like, it's the same way of writing those two functions. But we can do this much better, and we can write this piece of code much better, and we can make it much shorter. So when we were talking about when you have a map function, you know that you will get index in here, and you can like do something with this index. Let's say we can, I don't know, put the number of our Pokemon in before the Pokemon name French, and you just remember it starts with 0 and Pokemon start with 1. So we will increase it by 1, and after that we will write Pokemon name French. Remember, this is a thing we can try it. So it's like 1 Bulbapedia and 23 is Albo. Okay, fine. So why am I writing this? Because if you have only one parameter in your arrow functions, you can write it like this. So I will comment this out. Let's say get French Pokemon name is equal to Pokemon . So what we can do here is actually, if you have exactly one parameter, we can write it like this. So without the brackets. Okay, so that's maybe shorter to write, but I can make this like more shorter, even more shorter, and that is we can delete actually this brackets here, and we can delete return. So this is also totally legit way of writing if you want to try it out. Oh, get English. I am an idiot. So it's get French Pokemon name, not English name. So if you try this out, you'll see that the results are totally the same here. Okay. So this is the same thing as we read before, but what are the problems? So our function needs to have only one parameter if you want to write it like this. So this part, and this part means that there will be only one statement line inside of body of our arrow function. So if you have two different lines, and that statement line should be the return one. So this is like, I don't know how it's called, but I call it implicit return. So this is like implicitly return out of a function. So just to remember, what we have deleted here is actually return Pokemon name French. We actually just deleted the return part, and we created one-liner here. So it's totally the same. So you can try it out and try to run this. So those two ways of writing are totally the same. Why is this like better? Like we define the function, it's like one row and not 3 rows. That doesn't seem like to be a really great thing. It's that we can just like copy this and paste it here. And what we got now is actually a really readable line. So we don't need, if you don't need that function to be called somewhere later, we can write something like this. And this will what it reads really easily. So map all our Pokemon array as that each item. So it should be called Pokemon. Let's call it P at this example. So so our item called P is returned as p.name.french. So this will go through all our Pokemon and create a new array with just French names of our Pokemon here. So let's double check. Yeah, it works. This is a great way of writing your code. It's more readable, it has less lines of code, and you don't need to have like thousands and thousands of functions because you're doing some transformation here. Okay. Another thing that I wanted to show you is if you want to return an object and not just one string. So we want to create a new, so we want to return English and French names in this function. What we can actually do here is we can write something like this. So let's try to do it together. So what? We will map through all our Pokemons. Let's call item P, so each Pokemon is called P. And we can return actually here, return a new object that has French name equals p.name.French and English name equals p.name.English. If we try to run this, so if we try to run this giant piece of code, we will actually get, yep, you can see a new array of objects that each item in this array has French name and English name in there. But what we can do is make this a lot more readable. Remember, we can return, like just remove this return. But when we are returning an object, you will see that it will automatically, like, something is not great here. What we need to do is put new brackets around this object here. And what we'll get, have I written this fine? Oh, there are just a lot more. Let me. So what we created actually, we can do a one-liner here. Actually, we don't need like 2 lines. It's readable here also. So this does the same thing as the statement that we wrote before, and we can try it. You will see they're totally the same. So what this does is gets every item in the Pokemon array, and after that it returns a new object that has a property French name and property English name. These are just alternative way of writing something. This is just a quicker, much more readable way. I'm not sure if you agree with me that this is much readable because it's maybe new to you, but believe me, when you're trying to create a giant application, this is much more readable than all the functions that we can be defined, that will be defining like this. So okay. So remember when we were creating people like person A, person B, and so on, we can try to write it here just to show you how to create a quick function like create person. So create person equals to name, surname and age. And after that, we can actually just return an object, a new object, and we can write it out. Name equals name, surname equals surname, age equals age. So when your parameters, so we can call that. Let's call before we go and talk about this more. So create a person function, let's call with David, surname Abram, and age is 30. Okay, so you can see this is just a function, and we are calling function and logging out its result. Okay, here we go. Let's try it. So you can see there is an object, name, surname, age written out here. So we are using the new syntax. We will use this in the future a lot, maybe even exclusively. So if your parameters are called this, so if your parameters or your variables that you define in this function are the same as the properties of some object, actually there is a shorthand. You can just delete this part. What this will do is the same result that we get when calling the first thing. We can try it out. Yeah, it's totally the same. It's just another way of writing your code. Yeah, pretty cool. We actually can do, again, put this in one liner. Yeah. So create person, you get 3 parameters, and you return an object here. Yeah, pretty cool. Any questions, guys, about this? I know this is just a whole lot of new syntax, and it can get really confusing. So I now understand why I'm not seeing clearly everything, because I don't have my glasses. Okay. If there is any questions, I will stop and answer your questions. No problem with that. Okay, so this is like a way of writing your functions like easier. So let's try to do something with that. Let's try to do something with our Pokemon. So what we can do? So if you, let's first comment this out so we don't see the same console logs again and again. If you've seen here, there are a lot of Pokemon, so 809. There is an easy way how to select only few of those. Let's say first 20 or like second 20 or something like that. There's an easy way, something called slice. So let's try first and use slice. Slice is a method, and if you can see here, it actually says here start and end. If you enter the position of your starting item that you want to get, and you return like the last end here, what actually will happen here, you will get first 20 Pokemons in a new array, and it will console logged here. So we can try this out, and you will see we just got our first 20 Pokemons in here, from Bulbasaur to Raticate. If we want to get second 20 Pokemons in here, we can use slice on beginning on 20 and ending on 40. Try this out. There are 20 Pokemons here, 20 Pokemons here. These are from Sparrow to Wigglytuff. So this is just another method that's used often in arrays. And again, if it returns the array, and you can do something like this in this. So map Pokemon is, I don't remember the name, English. So p.name English. You can like pipeline it again with your maps and reduces and filters and so on. We can try this out. You will see that you just got first 20 names of Pokemons, or 20 names of your first Pokemons, or names of your first 20 Pokemons. Same stuff. You can try to do this also in the second row. So you will see we will get names in English names of our first 20 Pokemons, and then we'll get French names or our second 20 Pokemons. So slice is pretty cool. You can use it in your map filter and so on. The best way of actually writing with slice is to use slice first if it's possible. So first try to reduce the number of your items in a array as low as possible. So that's, yeah. So yeah, so Pokemon also have different types. So what we can do is try to use filter. Why I want to use filter on the types? Because type is actually an array. So property type in our Pokemons is actually an array. And Pokemon as much as I know, they have maximum 2 types, if I remember correctly. So what we can do here is we can try to get all Pokemons that have type, let's say, water. There are some water type Pokemons in there. So what we can need to do, if you remember last time, is actually use filter. So filter uses, we need to pass a function that returns something true or false. And here we can write something like p type. Remember, something called includes. So what this will do is actually will return all Pokemons that their type array, so the type here, includes water in there. If we try to run this, we will get, oh, what's the problem? Let me double check our data. Pokemon that p types includes water. Why is that returning? Where did I failed? P type includes. Oh man, I made a mistake somewhere. And why is that? Filter. What? Oh man. Wrong type of brackets here. Oh man, this is a function. See? It's written like this. Sorry guys, I have made a mistake. Yeah, okay, fine. Yeah. So there are 131 Pokemon, water type Pokemon here. Yeah, so Turtle asked type is array. So if you look at this data here, you'll see that type property in our array Pokemon item here is actually an array. You can have like an array of arrays, and I will show you what to do with those. So actually what can happen, and I will show you. What I will show you in the next line is a way to flat all arrays and arrays. But let's go through these motions here. What I want to show you is actually 2 more stuff. It's not filtering, but it's actually you will get a truthful or a false statement from them, and they're called sum. You can just copy paste, and array. So what this line does is actually same as filter. You need to pass something that returns true or false, and what will happen is this will return true if some of the Pokemon's type include water, and this will return true if every Pokemon is water type Pokemon. We can try to like negate this. Let's try to write human. There is no human type Pokemon, and like I don't know if there is no way of negating this, because like there is no type that every Pokemon is type. So we can run this, just you see, you'll be returned true, false, or something like that. So sum and array are pretty good because you can like check something like really fast with them. So let's say let's take an example with this Pokemon sum. Let's go to our browser. So we just we'll copy paste this. So are there some Pokemons that are type, I don't know, fire? Yes, there are some. Okay, great. Are there some that are type, I don't know, rock? Okay, there is rock type Pokemon. Is there some metal type Pokemon? No, there is no Pokemon like metal type Pokemon. Also, you can try something else. Let's say we can also do something like that. What this does actually is it goes through every Pokemon and tries to find if, or we can do it like this, way better. Are there some Pokemon names in English that are undefined? And we can try it. There are. No, there that are. I wrote it wrongly. So if there is every not defined. Oh, it's true. Okay, fine. I got confused. So this what we try to do is to see that there is no undefined like Pokemon with their English name undefined. You can write something like this. Yeah, this is just a very useful thing when you're writing some code and you need to check if there exists something or that every element in that array has something the same. Yeah. And let's also try to write out something like this because I want to show you something called flat. Pokemon.map Pokemon p.type. So let's try to console log this. It's pretty simple. You'll get an array of types. But as we remember that type property is actually an array, we will get array of arrays. And it can be really confusing because it's really hard to imagine this, how it functions and what it does. Actually, what this does is actually a 2D array. So let's imagine like 2D table. What we can do with this, let's save it in some, or not this, but let's try to take this one. If we try to save it in some variable here, so let types equal Pokemon, we can imagine this as a 2D table, so with two different dimensions. So we can try to call something like this. So if we call types like on the first position, we will get an array, grass and poison. If we call again 0, we will get grass, because this is get me first position of our first array and then get me an element on the also first position in our second level of array, right? It's actually really confusing, and there is a way that you can actually flat that without any problems. And that's actually if we call types dot flat. What this does is transforms array in everything like array in arrays. So it actually concatenates every like second level array into first level array. So actually, if you can see here, our arrays will be our array and array were grass, poison, grass, poison, grass, poison, and you can see here in the end grass, poison, grass, poison, grass, poison. Actually just flats it out. So there is also this is not really that often used, so you don't need to know this by heart. I'm also like, I have problems with using those. So there is also something called flat map and so on, but it's really not useful in our use cases. So let's totally forget about it. This is just a way, if you find like a array in arrays, you can just call flat and it will just flatten it out in a single array. But the thing that I want you to try to do with me is actually to see if my original idea with types is correct, that like every Pokemon can have 1 or 2 types. And I think that 2 types are the max. Like it's the maximum number of types that the Pokemon can have. And I wanted to try and to write a quick lambda function that will show me if there is any like Pokemon with more than 2 types. What I want to show you in this is another like bit of synthetic sugar, and that is a way to another piece of synthetic sugar, and that is how to create if else a little bit more shorter. And what version, like I will show you, just I can't even explain it to you in words how great this is. So if you have something like this, if you have let value and so on, and we try do it something like this, let's say we have some value and we want to try if number is like 1 or it's not 1, and we want to save it to the value. We will write like now if number equals 1, then value will say let's say just 1, and if it's not, we can write value it's not 1. So, and we can console log the value here. So this really tiresome way of writing this, and we can try, it says 1, if it's 1, if we change the number to 2, it will say it's not 1. This is really tiresome way of writing because I wrote something that's really easier to grasp, like in 6 or 7 different lines. What we can actually do is something in just 1 line of code, and I will show you this how it's made. The problem in there is you need to have only 1 thing to test, and it should be easy, and you will need to have something that it does if it's true and if it does if it's false. So if we want to define some value to the variable value, if a number is equals to 1 or if it's not equals to 1, you can write it like here, like this, value, or we need this number actually. Oh man, let me delete this. Actually, it's just for some, you can see, you can write like this, value, then number equals 3 times equal 1, question mark 1, so try this. writing this one. And we can try it, not 1, because number is 2. What actually this does is it says, okay, if number is 1, give me the value 1, or if it's not, give me not 1. You can try it, write this 1 and refresh it, and it says 1. So this really popular way of writing your if-else's in React is really popular. So you will see, if you read a lot of React code, you will see a lot of this. And this is also actually called tertiary operator. And I will just Google it because I'm not sure how it's called actually. Ternary, not tertiary. Okay, ternary. Ternary operator in JavaScript. And it's called conditional ternary operator. So it's conditional ternary operator. Okay, so this is called conditional ternary operator in JavaScript, or like, I don't know. It's not really, but it's not really great name. It doesn't roll off your tongue, but you have something truthful here, and then 2 values that value will get. If this is true, it will get 1. If this statement here is true, it will get 1. If not, it's not 1. So the thing I was talking about before, I think that every Pokemon has like max 2 types, but we can test this out. How? Really easy with that. What we can do is actually say const is max number of types. What we can write here is actually first map. So we'll get only the types of our Pokemon and not the names and so on and so on. And after that, if you remember, we can reduce, so we will get the maximum number we can get like a maximum value of something via reduce. If you remember, we done it before, and you can write it like total, and I don't know, like how we talked about total and value, right? Our value will be actually the p, like the types. So maybe let's say type here. Then we can say the arrow, and then we can say something like this. Remember the conditional ternary operator, so this part. We can say if total is less than value dot length, pass value dot length. So that means that our type, so we have more types in our array than we have in total. So return value dot length, so the number of our types in our the type array, or return total, and total starts at 0. So not value, sorry, it's type in this. Yeah, so what this does is actually takes total, that's initial value is 0, and it says, okay, if my total is less than type length, then return type length. If not, then returns total. And what will this do is actually, it will get the maximum number of our, oh man, let's try to console log this out. Max number of types. Let's try to go like another times through this. So create a new array of just Pokemon types, and we will get like big table, like 2D table there. After that, we will reduce that to get the maximum, like the biggest, so the biggest array, or the maximum length of our array, type array, right? And then what we can do is actually create the total that has initial value 0, and see if total is less than our type length. So this will be the element in array, another array. And after that, return, if this is true, return if type length is bigger than total, return type length, or not, return total. Let's try to run this. 2. We get the number. Yeah, it's 2. So there is only 2. The maximum number of types that the Pokemon can have is 2. So that's great because there is like different types in there. And what I want to do on Saturday is actually like show the image of Pokemon. So let's say Bulbasaur. There is an images folder here with a cute Bulbasaur picture here. And what we can do is actually show this picture here. And in the background of the picture, we can color it with 2 different colors, as there are maximum 2 different types. So let's say grass and poison. Grass is like green and poison is like purple for some reason. So the background of Bulbasaur will be green and purple. And that's a great thing because there is maximum, as we showed here, 2 types. So it'll be like half-half, like a flag behind our Pokemon on Saturday. I will show you that I have some design skills on Saturday. Yeah, that will show Danica. Okay, so if there is any questions, just ask me, because I want you to we can go through the example, at least the exercise that we do on Saturday, at least explain the concept behind it, what we will do actually, and what I want to create. And we can go then through our exercise from the weekend before. So Toril already asked me a question, and let me find you a best way from Ray. There are different ways of using it, but there is so if we have to remove or unique in array of array. So the question of Toril asked me, how could we get unique values of types from the 2D array? If we want to get it like result in only like a 1D array, that could be quite easy. So let me try to do that. So this is live coding. You can ask me any live code questions. Maybe I will be using Google a little bit, just so you can, yeah. So there is a trick with filter for finding unique numbers. And it's really hard to explain, so I will try to explain it correctly. Let's try to get an easier, or we can use the types. It's not that complicated. What we create, we'll create a 2D array. So let's say Pokemon.map p.type. So if we console log these types here, you will get an array of types as we had it before. After that, what we can do is actually just call this to be flatten. So call flat, and we will get like everything. Yeah, I'll show you now, because if you have 2D array, okay, I will explain you another way later. So we have like just a giant like 1214 different types in this array. What actually we can do is actually filter. We can use filter to get only uniques in there. So it's kind of hard to explain, so try this with me. You will need actually the p. So this is our this is actually our type array in there. This is actually our type in now, because we flatten everything. We need index for here, and we need our array. So original array is this bunch of different types. Our types is each element in that big array, and index is the position of it. And what we need to return here is actually oh, I haven't shown you the index of. Okay. I'm missing one part in here. So this one. There is something called index of. We can try here. Let's try to copy paste this. We can try it here. So types index of is grass is 0. So what this does is actually it writes out the first index in our array, or the first position where our element or where our item is positioned. So grass will be 0, poison will be 1, let's say fire, capital will be 6, like 0, 1, 2, 3, 4, 5, 6. Yeah, it's working 5. So let's say flying will be 9, and so on and so on. But this gets only the first position of our item. So what we can do here is after flat, we can just call filter. We need to get all three, so it will be, here will be type, index, and array. And we will return, so array dot index of type equals to index. Or we can write this a little bit more. Yes, we can write it like this. This will be much nicer. So what is going on in here? And I'm missing one. We can also like write it like this. It's the same thing. You can do it multi-line like this. So what we want to see here. So let's try to go through our example here. So what's this? So if we call index of grass, so value will be 0. So this position of this item here of grass, that this grass is on 0, but this one is on 2. So if it we can see what's the first index of, or what was the first position of first occurrence of grass through the index of, and we can like just try to compare the position of our first occurrence to the index or position of our current grass here. So this one will be like 0 equals 0 and it's true, and it won't be filtered out, but it will be added to our new array. And this one will be filtered out. So let's try to console log this. I will just copy paste this in chat. Yeah, 18. There are 18 types with the new generation. So, okay, again with this filter, we are trying to find if the first occurrence of our type is also is the same as the index of our current type in our array. So what that means is actually that it will filter any any other, let's say, grass type after the first one, and we will get the These are just unique elements in here. It's quite a trick, yeah. And I totally forgot about index of. Index of is not really super useful because it only gets the first occurrence of something in an array. So yeah. Does this answer your question? If you are confused, that's totally normal. I was also confused with this solution when I first time I saw it, but it's quite elegant solution. And this index of, I'm not sure that's used anywhere else. Let's see on our documentation. So let's try to, I have a link to documentation here. Let's see this. So actually you can pass, can be far, or if it's not present, start from index 2. Actually you can start from any index. So you can, index of is useful for something else. I haven't noticed. I mean, you can see that only array has like 50 or 60 different, maybe some obsolete, but has a lot of different methods, and some are more useful and some are just, I haven't seen like the use of those. There is also last index of, so it works in the reverse. But reduce, map, filter, those are really great methods for array. Yeah, totally. This is totally strange. I haven't known this at all. So index of is kind of more useful, but you can call like you can call slice before it, and it gets similar results. Yeah, okay, fine. I learned something today. Of course, there is also a string index of. It works similar, only not with arrays but with strings. And if you have ever tried to do something like this, let's say const name equals David, and then call name.0, you get D. A. So strings, to some extent, they behave similar to arrays with those some things. So you can do easy slices and so on, except like on strings, the method for, is there a slice method? Let's try. Yeah, there is a slice method. Oh, great. But there is also substring method. Okay, slice is pretty nice. Slice is really useful in here. So they have some similar methods, and they behave in a similar way if you try these things. Yeah. So okay, guys, any more questions? Ask me. Has anybody completed the tasks from the last exercise? Anybody tried to do that? Anyone? Actually, I know at least one person tried because we talked about it. And yeah, the table one is quite harder than change image one. The change image one is kind of straightforward. And it can be written much better because remember, for today, you can use for this. So this is a great use case for the for. I have automatically created for, so we can say index is less than 20, index plus plus, add new image. Yeah. So we will create 20 images in this example. Let's open up this. So exercise 2 example. We'll get here. Yeah. So what I wanted to create here is actually, so every time we go over the image, so on mouse enter, it creates a random random image here. What we can do here is actually we can write this function, these two functions a little bit better. So we can reuse, like, these two lines are awfully similar. We can rewrite this, but let's not dwell on that. So we actually create a new image element here. We get random numbers. We say that source of that image is like source unsplash random with those two as dimensions. And after that, we set the change size function to on mouse enter, and we add it to the child. And every time we enter with mouse on that image, we actually call this function. So let's try it. It loads actually. What's the problem? Has my internet failed? No, my internet works pretty much. Okay, so their service of Unsplash is really slow. Okay, but you remember from the last time, yeah, it's crazy slow. Something is not working with their service. Okay, it doesn't matter. Okay, but that's about it. So this is quite easy. This on mouse enter is really important because we'll use this for some other stuff in the future. And random, we talked about random in our head, shoulders, knees and toes example. So yeah, that's pretty cool. Okay, and let's talk about table a little bit. So this is quite hard. So if you try this and failed and tried it for a few hours and failed, that's totally fine. You're not behind. This is just quite hard for a programmer that just started. This is not really an easy task, so don't worry about it. Also, there are some stuff that I haven't talked about, maybe Danica talked about, like on this Monday, about these selectors. And we can talk about also this insert before that creates, so this, yeah, so we can talk a little bit about this. So these selectors, so let me try to open this index.html. Here. So when you try to select something with document, so remember query selector and let's say table. So we selected table. If you want to get, so this t-body here, and you have multiple t-bodies on your website, in this example we don't have, so we can get just with t-body. But if you want to be 100 times sure that you are you're getting the t-body from your hashtag table, so this is actually the right hashtag table. If you want to get the right t-body and it's directly a child of our table element, you can actually write something like this. So this sign actually says like first child of table element. So get me a first child element t-body from an element that has ID table. So if you want to get like table rows, or like let's get first table row from here, we can actually write something like this. We will get the first table row from it. So we said, get me a child element table row from tbody that's child of an element with ID table. It's just a cool way of writing it. If you remember, when we tried to let me go to the elements. When you tried to press the right click to the tbody here, and then go to copy and copy selector and paste it, you see, you'll get something like this. Because this is the best way to get exactly that element. So if you try to click on any, like let's say on our button here, right? Right click, copy, selector, and you will get, oh, it's commit actually. So this is the best way to get this element. So you don't need to think about it a lot. You can just double click and see what's happening here. So the other stuff here is actually just query selector and create elements. Remember, you can add child to any element. So in this example, we are adding to remove TD element, and here we are appending child to tier element. The one inserted before, it's a little bit different than table element append child. So what append child does is actually it appends that element as his last child. If we want to append that element as a child, like a second child or a third child or something like that, we actually need to use insert before. So insert before does, it needs to get element that we're inserting and a child from this element that we want to insert before. That's why it's called insert before. So why we are inserting this example before the create new person or element with ID create new person is because we want to actually, let us double check this. We actually want to insert in between those two TRs here, because we can try entering here. Actually, you see, it actually created like in between those two TRs. If we change this code to append child, actually what will happen here is, let me check, 30 create, it will add to the end. You see, so it's fine, but it's not what we wanted. So, any question, guys? If there are no questions, I will be here on Saturday early morning creating some cool websites. So I hope that you understood what I was talking about today. If you have any questions, just go to Slack, go to our CroCoder there, and I will answer anything that I will answer any questions that you have. Also, try to if you're not subscribed, please subscribe and please thumbs up. I heard that it helps a lot on YouTube channels. So yeah, that's about it. If there are no questions, I will wait for a few minutes more, but if there is not, I will just end the stream. So yeah, so if you have, so Daniel said that looks so easy. the problem with programming, so what programmers do is not really writing code. Programmers actually try to understand concepts and create code that solves the problem. So you need to conceptually understand everything and then to try write code. It looks easy when I'm doing because I understand what I need to do and how to show you the example. But when you're writing, it's much more harder because it's not easy to understand the concept and then create code that does that it needs to be done. So that's why being a programmer is hard. That's the only hard part. So all the syntax that you learn, all like understanding variables and so on, that's totally secondary to everything. Now, what you need to understand are concepts, and that's why I really want to work with you on websites and web apps and not just show you some random code. Because when you try to write your own website, you will understand what do you need to do and how to do it, because you will know how to code, how to write a statement in JavaScript, right? So don't be discouraged. I spent a lot of time learning this. So maybe there are some people that are better at programming and some are that are worse understanding. But the only thing that you have to do to become better is just try to program. So try to writing websites and not just random pieces of code. So guys, that's great. There's some questions on Slack. I will answer them off stream. So because I don't know if I can share them on stream and not. So yeah. So guys, yeah, take care of yourself. Yeah, see you on Saturday. Bye guys.